Now for our next compound, here we've got NH3. The name is unusual. It's ammonia. That's one that you've got to memorize. The name goes all the way back to 1800, where they were finding some salts at the temple of Jupiter Ammon in Libya. And Bergman, a scientist there, said, hey, you know, this compound we're making, let's name it after the temple here, Ammon and ammonia. So there's an interesting origin, but one that you've got to memorize. It's not nitrogen triiodide, it's ammonia. We've kept the old word, and I'm sure they're never going to change it. But let's do the Lewis dot structure for ammonia. Pretty simple. We've got nitrogen and 3 hydrogens, so we'll do our valence electron things first. And here indeed we've got our hydrogen. Again, my arrow there. And we've got our nitrogen, so 5 valence electrons for nitrogen. One you probably should remember. And we have 1, 2, 3, 4, 5. And the hydrogen has only got 1, but there's 3 hydrogens, so we've got 8 valence electrons. So not that many electrons to play with, but it's a pretty simple compound. So let's make our molecule with a nitrogen in the center and 3 hydrogens around it. And see what we've got. Here it is. I've already put the 3 shared pairs of electrons that nitrogen is attracted, and nitrogen and hydrogen are attracted to. The nitrogen's nucleus and the hydrogen's nucleus that keep these 2 electrons in between them. So this is good. We've subtracted, we've taken care of 6 of the 8 electrons, and now we've got 2 electrons left over. Now the normal procedure is to take these leftover electrons and put them around the surrounding atoms to complete their octets, but this is our exception. Hydrogen is in row 1 in the periodic table. It only has the first energy level, and there's only room for 2 electrons, and those are already being shared here. So there's no more room to put these 2 electrons in the first energy level. So the exception is when you have leftover electrons, put them on the surrounding atoms, except for hydrogen, which you can't do. So this pair of electrons goes to the nitrogen, which is great because that completes its octet. So here we've gotten rid of all of our electrons. Nitrogen has its unshared pair of electrons and 3 pairs of electrons. Worthy of note, this shared pair of electrons for ammonia is a very attractive pair of electrons for other atoms. Sometimes this pair of electrons will actually make a covalent bond with an atom that doesn't have a complete octet, that needs 2 more electrons. It's called a coordinate covalent bond, and we'll see more about that later. But okay, we've got our Lewis dot structure, but let's go to the next step, which is an important one, which is to identify them. We have 3 sigma bonds, 3 shared pairs of electrons, and this is something new. We've got an unshared pair up here that completed our octet, and so we would end up saying that we have 4 domains. There are 4 basic clouds around our nitrogen, so we have a steric number of 4, and that's going to dictate a very unusual structure for this. Now this Lewis dot structure doesn't really give you the 3-dimensional nature of it, and we'll deal with that later. But there we go, ammonia, and we've got it all figured out nice and quickly.